In 1988, a computer scientist named Norm Hardy described a security problem he had observed in a compiler system. The compiler ran with elevated privileges. It had the authority to write output files to disk. A user who ran the compiler could direct its output to any file path they named. And a user who wanted to write to the billing records, a restricted file they could not access directly, could name their output file to point there. The compiler had the authority to write to that path. It would write there. It followed the instruction it received. The compiler was not compromised. It was not exploited in the way practitioners typically use that word. It was used. It had a capability. The user directed it toward a resource they could not reach on their own. The compiler could not tell the difference between a legitimate instruction and a malicious one. It acted on both. Hardy called this the confused deputy problem. The compiler was the deputy, a trusted intermediary with elevated authority, acting on behalf of whoever gave it instructions. It was confused. It lacked the ability to verify whether the entity directing it had the authority to send it toward that particular resource. It carried out the request regardless. The mechanism is nearly 40 years old. It is the structural basis of some of the most impactful attack classes in modern cloud environments. A confused deputy attack requires three things: a service, the deputy, that holds elevated permissions, a resource or action those permissions can reach, and a path through which an attacker can control what the deputy does without holding those permissions directly. The attacker does not compromise the deputy. They instruct it. The deputy's own permissions do the rest. The property that makes this possible has a name: ambient authority. A service with ambient authority automatically applies its permissions to every request it processes, without verifying whether the entity that originated that request had the authority to direct those specific permissions toward that specific resource. The authority is ambient, always present, always applied to any request the service handles. The service cannot see past the request to the authorization context behind it. In AWS environments, the most widely exploited form targets the EC2 Instance Metadata Service. An EC2 instance with an attached IAM role can retrieve that role's temporary credentials by querying the metadata endpoint at 169.254.169.254. Any process running inside the instance can reach this endpoint. Any process that can reach it will receive the credentials. An application on that instance vulnerable to server-side request forgery, SSRF, can be directed by an attacker to make outbound HTTP requests. Directed at the metadata endpoint, the application issues the request. The metadata service receives a request from the EC2 instance, a trusted source, and returns the role's credentials. The application did exactly what it was designed to do. The metadata service did exactly what it was designed to do. The Capital One breach in 2019 followed this chain. SSRF through a misconfigured WAF. The application as the confused deputy. 106 million customer records accessed using the returned IAM credentials. AWS responded to this pattern by introducing IMDS v2, where the original service returned credentials in response to a simple GET request. IMDS v2 requires a preliminary PUT request to obtain a session token before any credential retrieval. An SSRF vulnerability that can only issue GET requests cannot complete the exchange. IMDS v2 is the specific architectural fix for this form of the attack, and AWS made it the default for new EC2 instances in 2022. Because the pattern had appeared in enough real environments to justify changing platform behavior. The second form is less visible and is built into the structure of multi-service cloud architectures. When you configure an AWS service, CloudTrail, Config, Systems Manager, Backup, to deliver output to an S3 bucket, you write a bucket policy granting that service's principal the permission to write. The service principal is shared across every AWS account that has configured that service. It is not your CloudTrail. It is CloudTrail as a service, acting across all customer accounts. Without a condition that restricts the service to acting on behalf of your account specifically, the bucket policy grants write access to cloudtrail.amazonaws.com from any AWS account. An entity in a different account who can invoke CloudTrail could, in certain configurations, direct it to write to your bucket. The service has the permission. The bucket policy allows the service. The authorization context, which accounts resources should the service be acting on behalf of, was never verified. AWS documented this vulnerability explicitly and introduced condition keys to address it. A policy that includes AWS SourceAccount restricts the service principal to acting only on behalf of a specific account. A policy that includes AWS SourceArn restricts it further to acting on behalf of a specific named resource in that account. AWS now has dedicated confused deputy prevention documentation for CloudTrail, Config, EC2 autoscaling, Systems Manager, CloudWatch logs, and dozens of other services, each specifying the exact condition keys required to close this exposure. The presence of that documentation across the service catalog is the clearest indication of how widespread the underlying pattern is. The oldest widespread manifestation of the confused deputy in web applications is cross-site request forgery. The browser is the deputy. It holds authenticated sessions with websites. A malicious page can cause the browser to issue requests to those websites using those sessions. The receiving server sees an authenticated request arriving from the correct browser. The session token is valid. The request reaches authenticated endpoints. The browser executed an instruction it received from a page the user visited, applying its ambient authority, the authenticated session, to a request the user did not intend to make. SSRF tokens and same-site cookie policies are the mitigations, and both work by the same mechanism. Adding authorization context, the server can verify that a forged request cannot supply. The session proves the user's identity. The SSRF token proves the request originated from a page the user was legitimately on. The browser's ambient authority is constrained by requiring evidence that it is acting on the user's actual behalf, not on an instruction from a page they never trusted. When a confused deputy attack succeeds, the logs show what a defender least wants to see: a legitimate service, operating normally, making requests it was fully authorized to make. The audit trail is clean, every action was permitted. The authorization context that should have governed those requests was never checked and therefore never appears. Every environment contains services that hold permissions they apply to all requests they receive. The security question for each of them is the same one Hardy identified in 1988. Whether the entity giving the instruction has the authority to direct this service toward this resource, or whether the service is simply following instructions it has no way to verify. In most architectures, that question has been asked of some services. The ones it has not been asked of are the ones currently waiting.